Hi everyone, good to have you in class today. This is A Plus Academic Resource Center where we take online tutorials for undergraduates and senior secondary students. Thank you for liking our pages, thank you for subscribing, thank you for sharing, thank you for the support. Okay, quickly, we're going to be looking at indices, okay? Now, indices, we're going to be looking at the laws of indices, and there are about 7 of them. There are about 7 laws of indices. Now, number 1, we have, let's say if a raised to power m times a raised to power n is same thing as a raised to power m plus n, okay? A raised to power m times a raised to power n is equal to a raised to power m plus n, okay? An example of that would be, let's say for instance, we have 3 raised to power 2 times 3 raised to power 4. The same thing as saying 3 raised to power 2 plus 4, okay, which is equal to 3 raised to power 6, okay? This is the first law of indices. So when you have a number, the base is the same, but the powers are different, you just bring one of the base and add the powers when it's multiplication, okay? And number 2, we have if a raised to power m divided by a raised to power n is something as saying a raised to power m minus n, okay? So here is just you minus the powers. You bring one of the bases, then minus the powers. An example of that will be 3 raised to power 4 divided by 3 raised to power 2, for instance. So we'll have 3 raised to power 4 minus 2, which is equal to 3 raised to power 6, okay? So this is a typical example of what the second law is all about. Then number 3, we have if a raised to power m divided by a raised to power m. Now in this case, the bases are the same, the powers are the same. So you have a is equal to m minus m, which is equal to a equal to 0. Equal to a raised to power 0, sorry, okay? So in this case now, a raised to power 0. And in the laws of indices, whatever number that is raised to the power of 0 is equal to 1, no matter the number. Once it is raised to the power of 0, it's equal to 1. So in this case, let's look at a typical example. Let's have 3 raised to power 3 divided by 3 raised to power 3. So you have 3 raised to power 3 minus 3, which is equal to 3 raised to power 0, which is equal to 1. Okay? This is the third law of indices. So we have 3 raised to power 3 divided by 3 raised to power 3 equal to 3 raised to power is equal to 3 raised to power 3 minus 3 raised to power 0 equal to 1. Okay? Then number 4, let's have number 4. Let's say we have a raised to power m, all close brackets, n, outside. A raised to power m, open and close brackets, raised to power n. Okay? The same thing as saying a raised to power m times n. It can also be rewritten as this, a raised to power m times n. Okay? So a typical example, let's have 3 raised to power 4, close and open brackets, raised to power 2. The same thing as saying 3 raised to power 4 times 2, which is equal to 3 raised to power 2 times 4, 8. Okay? This is a typical example demonstrating or illustrating this fourth law. Are we together? Okay, let's look at the fifth law. Let's have a raised to power minus m. A raised to power minus m. Okay? A raised to power minus m is same thing as saying same thing as saying 1 all over a raised to power m. Okay? 1 all over a raised to power m. This minus here automatically becomes the division. So we have 1 divided by a raised to power m. A typical example, let's see 3 raised to power minus 2 is same thing as saying 1 all over 3 raised to power 2. Okay? 1 all over 3 raised to power 2 for the fifth law. Then, okay, So we have law 1, law 2, law 3, law 4, law 5. Law 6, let's have a raised to power 0 divided by a raised to power, okay, no, this should be law 6, a raised to power 1 over n, okay, 1 over m is same thing as saying m roots of a, okay, 1, a raised to power 1 divided by m, same thing as saying the m roots of a, okay. Now the laws, let's say, okay, let's have an example for this. Let's have 3 raised to power 1 over 4. It's same thing as saying the fourth root of 3, okay. Then the seventh law, let's have a raised to power m all over n is same thing as saying the nth root of a close and open bracket raised to power m, okay. A raised to the power of m all over n is same thing as saying open and close bracket the nth root of a raised to the power of m. For example, let's have 16 raised to the power of 2 16 raised to the power of let's use, okay, let me use 32 raised to the power of 2 over 4, for instance, okay, it's same thing as saying the fourth root of 32 close and open bracket raised to the power of 2, okay. So this is what these are the basic laws of indices, the fundamental laws of indices. Let me go over them again. A raised to the power of m times a raised to the power of n will give you a raised to the power of m plus n and all that. Then the second law, a raised to the power of m divided by a raised to the power of n is equal to a raised to the power of m minus n, and like that. So these are the fundamental laws that we're going to be, the fundamental laws of indices that we're going to be using to solve some problems as we proceed. Okay, I'll need to wipe this off. So we're going to be looking at some problems involving indices, the knowledge of indices. So let's look at some equations involving the knowledge of indices. Let's have x raised to power 1 over 2 equal to 3. Let's have 3x raised to the power of 3 equal to 24. Then let's have 5a raised to the power of 3 equal to 1 over 25. On the other hand, let's have 4 raised to the power of x equal to 1 over 2. Then 5 raised to the power of 2x plus 4 equal to 1. Then let's have 3 brackets, 3 raised to the power 2y minus 6 close bracket equal to 27. Okay, so these are equations involving the knowledge of indices. Why these are exponential equations? Now the difference between this equation and this equation is this: the powers here are unknown. The powers in these equations are unknown, while the powers here are known. So these are the difference between these two equations, two sets of equations. Okay, so let's solve them one after the other. Okay, all right. Number one, here we have x raised to the power of 1 over 2 equal to 3. Now, how do you solve this? Now, the multiplicative inverse of 1 over 2 is 2 over 1, or just 2. That's the multiplicative inverse of 1 over 2. So the multiplicative inverse, you do the multiplicative inverse on both sides of the equation. This is what I mean. Now, solution. We have x raised to the power 1 over 2 times 2 over 1 equal to 3 2 over 1, or 2. Simply 2 is the same thing. Okay, so this will cancel right off this. So we have s is equal to 3 raised to the power 2, which is equal to what? 9. So that's it. You look for the multiplicative inverse of 1 over 2. The multiplicative inverse of 1 over 3 is 3. The multiplicative inverse of 1 over 4 is 4. So the multiplicative inverse will be added on the other side of the equation. Do you understand? Then number 2, we have 3x raised to the power of 3 equal to 24. Now, if you check this equation, 24 is divisible by 3. So let's divide both sides by 3. So we have 3x raised to the power of 3 equal to 24. Divide by 3, divide by 3. 3 will cancel 3. 3 here 1, 3 here 8. So s raised to the power of 3 equal to 8. Okay? So now this equation here is looking like the first one. So we'll look for the multiplicative inverse of 3. Now the multiplicative inverse of 3 is 1 over 3. Just the opposite is 1 over 3. You know, in this case now, the multiplicative inverse of 1 over 2 here was 2. But here now we didn't have 1 over 3 as the first case. Now it's just 3. So the multiplicative inverse of 3 now will be 1 over 3. So we'll have x raised to the power of 3 times 1 over 3 equal to 8 raised to the power of 1 over 3. So 3 will cancel 3. So we're left with s equal to 8 1 over 3. Now, if you check our laws of indices, there was one law that was looking like this. If you remember, there was one law that was looking like this. So here now we need to apply that law. I think either the fourth or the fifth law. So s is equal to the cube root of 8. Okay, the cube root of 8. The denominator will take the roots. Okay, now the cube root of 8 will be 2. That's our answer. Okay, now the third one, which is this one. So we have 5a raised to the power of 3 equal to 1 over 25. Okay, let's solve this. We have okay, 1 over 25. Let's divide this other side by 5, so that we'll be left with a raised to the power of 3. So we have 5a raised to the power of 3 equal to 1 over 25. Divide by 5. Divide both sides by 5. So we'll have 5 will go here, 5 will go here. So a raised to the power of 3 is equal to 1 over 25 divided by 5, which is the same as 1 over 25 times 1 over 5. Okay? So a raised to the power of 3 is equal to 1 times 1 is 1. 25 times 5 will give us 125. Okay? Alright. So now we have a raised to the power of 3 equal to 1 all over 25. Now how do we solve this? How do we solve this? This is looking like the first one here. These are our question here, number 1. You see? So look for the multiplicative inverse of 3, which is a raised to the power of 3 times 1 over 3 equal to 1 over 25, 1 over 125 raised to the power of 1 over 3. Okay, 3 will go here, 3 will go here. So a is equal to the cube root of 125. Sorry, of 1 over 25, 125. 1 over 125. Okay, so the cube root of this will give us 1 all over 5. The cube root of this will give us 1 over 25. Let's confirm. 5 times 5, 25. 25 times 5. 5 times 5, 25. 2 times 5, 10, 125. Okay, so that's it, 1 over 5. So that's that about this question involving the knowledge of indices. Now let's solve this exponential equation. There are 3 of them. 1, 2, 3. There are 3 of them. So I'll quickly wipe off this. So number 1, we have 4 raised to the power x equal to 1 over 2. Now solution. Now in this case, you would ensure that the base are equal so that you can solve for the exponents. You can solve the powers. That is a fundamental rule when solving exponential equations. You ensure that the bases are equal so that you can strike them off and solve for the exponents. Now 4 raised to the power of x is equal to 1 over 2. Now how do we make the bases the same? Now 1 over 2 is same thing as 2 raised to the power of minus 1. I hope you remember the law of indices. I think the second or the third law. no, sorry, the third or the fourth law, where 1 over a is equal to 1 over a is something as a raised to the power of minus 1. The same thing. Okay, so now this one can be broken further into 2 raised to the power of 2, because 2 raised to the power of 2 is 4. Okay, x equal to 2 raised to the power of minus 1. So you see, the bases are the same, so we can strike them off and equate the powers. So we have 2x is equal to 1. So x is equal to 1 over 2. As simple as that. Okay, then number 2, we have 5 raised to the power of 2x plus 4 equal to 1. Okay, so 5 raised to the power of 2x plus 4 equal to 5 raised to the power of 0. Anything raised to the power of 0 is 1. Remember, in the 6th law or so, whatever that is raised to the power of 0 is 1. So 5 raised to the power of 0 is the same thing as 1. Okay, so our bases are the same. We strike them off and equate the powers. So we have 2x plus 4 equal to 0. So 2x equal to minus 4. Okay, 2x equal to minus 4. So 2x equal to minus 4, yeah? Divide both side by 2, divide both side by 2. 2 will cancel 2. S is equal to minus 4 over 2, which is equal to minus 2. Because 2 here 1, 2 here minus 2. Okay? So these are answers. Then the last one we have 3 brackets, 3 raised over 2y minus 6, okay, equal to 27. Okay? So this is same thing as 3 times 3 raised to the power 2y minus 6 equal to 27. Now remember the law of indices. This one is same thing as 1. 3 raised to the power 1 is same thing as 3. Okay? 3 raised to the power 1 is same thing as 3. Don't forget. Now the law of indices, I think, yeah, the first law, where we have a raised to the power of m times a raised to the power of n is same thing as a raised to the power of m plus n. You remember? You remember the first law? Yes, so we apply that law here now. So we have 3 raised to the power of 1 plus 2y minus 6 equal to 27. Are we together? Are we together? Okay. Now, 3 raised to the power of 1 plus 2y minus 6 equal to 3 raised to the power of 3 will still give us 27. When we raise 3 to the power of 3, it's same thing as 27. So we strike off the base now and equate the power. So we have 1 plus 2y minus 6 equal to 3. So 1 plus 2y, or let's do it this way. 2y minus 6 plus 1 equal to 3. Okay? So we have 2y equal to, collect like terms, okay? You collect like terms. Collect like terms. So 2y equal to 3 plus 6 minus 1. Remember, when the number with the minus sign is crossing the equality sign, it changes to plus. When the plus is crossing over, it changes to minus. That's what we have here. So 2y equal to 3 plus 6 is 9. 9 minus 1 is 8. Okay? So divide both sides by 2. Divide both sides by 2. So you have y equal to 8 over 2, which is equal to 4. So this is how you solve for indices. Okay? So with this, we have come to the end of indices. In our next class, we're going to be looking at logarithm. Okay? So please, if you have any question, do not hesitate to use the comment section. Let me get your feedback, or if you feel there is a problem in indices that we need to solve together, still let me know. Bring it to my attention. We'll solve it together. Okay, we'll stop here for now. Follow all our social media handles. Don't forget to like our page, share, and invite people to be part of what we're doing. All right, thank you very much. See you in the next class.